Ready to go. All right, we'll get going here. You guys, Mr. AV dude, are you ready? All right. Well, awesome. Well, thanks so much, everybody. This should be pretty fun. This could be like we're going to start out with just a little bit of a product pitch, but we'll pretty quickly roll into like getting like deep technical about what it means to be doing payments on chain, because that's really like the hard part about this. Like, we're all talking about it. We had a great talk by Tomer earlier, and the fact is, like, what I'm going to spend a lot of my time talking about is like it actually is not as easy as like just sending money on chain and it's all done. Right? Like, you don't just go on chain, you hit send, and then you're done. The money flows over there. Like, there's all these business processes both before that button click and after that that button click that it takes to really make payments happen. So we kind of forget, like, Tomer made a really good comment, or maybe it was Amaya, which was like, we in the crypto space, we tend to think about the problems around crypto. We tend to think about the world in a very like engineering centric way of like, you build a L1 that does this stuff, but that's actually not like, that's not how businesses operate. Businesses have workflows and they have approval processes and all these different things that it takes to make payments happen in the world. So that's what I'm going to be talking about today, and then how we kind of fit into that. So thank you. All right. There we go. Does this work? All right. Awesome. So really quickly about Bitwave. Let me do this. Let me do this. Let me do this. Let me do this. All right. Really quickly about Bitwave. All right. So Bitwave, we're the leading digital asset back office solution. So subledger, tax, so accounting, tax, financial operations, payments, anything like that you need to do around digital assets, we can help you out with it. So today we're here talking about payments. We recently launched our big payments product, which is basically a enterprise institution focused payments product. So again, getting to this idea of like, what does it take to actually, like, we can all talk about payments, and like, we're all so excited about stable coins, and that's like the key magic thing here. But what does it take to actually make a payment happen? Like, what does it take? So our customers are folks like Nike and Coinbase and Magic Eden, and the biggest customers, the biggest clients in digital assets. What does it take for an enterprise to actually make a payment? It's not as simple as like you just open up your MetaMask, you hit send. You have to run through approvals and address validation, all that kind of stuff. So that's what Bitwave does in the broadest sense. Bitwave Payments is a product that's designed to enable your enterprise for compliant, workflow-driven payment execution. So what that means is it integrates deeply with NetSuite. So you pull up NetSuite, you can actually like integrate, you can get your addresses in there. It has deep vendor onboarding flows. So part of onboarding for payments is like, you need to gather these addresses, you need to penny test them, and you need to do that at scale. So if you're going to bring 1,000 or 5,000 vendors on, like something like Coinbase might, onto your payments product, you can't just, you don't just have them email you your addresses, right? Because that is incredibly dangerous, that like you transpose a character and suddenly you send a $10,000 payment to a null address or whatever it is. There's all these different things that can kind of happen there. So part of this is like vendor onboarding, penny testing, and actually verifying that the address you have is what they meant to get paid to. And then, of course, invoicing. So sending out invoices, this is all part of that. If you ever use QuickBooks, you ever use NetSuite or Bill.com to actually send invoices, what Bitwave Payments does is it builds on top of that to be a crypto compliant version of that. So it's a stablecoin first, but supports traditional rails as well, but stablecoin first model for getting payments made around the world. And then, of course, compliance is like the last thing here. So this is something that we all tend to forget about. But at the end of the day, if you are Coinbase, and you are paying a vendor for, let's say a security review or a bug bounty or something like that, you need to double check that the person you're about to pay hasn't been transacting with North Korea. Like, I know that's a silly thing to say, but like, this is a very real, like someone like Coinbase is a publicly traded company, gets into very real issues if they are not KYTing or KYCing every single customer that comes through. So that means that when you're about to send out a payment on chain, you need to actually look at the address that you're about to send to and verify that like do a real-time verification that they're not on an OFAC list, that they're not traded with North Korea. You need to do a risk analysis of it. So this is part of Bitwave Payments, is that before you actually do a payment, we check to make sure that it is valid, that it is not with North Korea, and that it is, and then we handle all kinds of remittance pieces and getting into your system and all of that. Okay, so the fun part, so that's the quick pitch. Thanks for bearing with me, guys. But if you need that, bitwave.io or find Amy. She's the salesperson here. So what I'm going to talk about today is actually really interesting, which is that, so if you kind of like couch what I was just saying, which is like, okay, I'm going to send you money. So I'm going to send you $100,000 on chain. There is nothing on chain that indicates what that is paying. So traditionally, if I'm going to wire someone money, what I do is in the memo field, I put in invoice number 12345 from this company. So if you're doing this through bank accounts, it's actually I wouldn't say it's easy, but it is a more tractable problem to figure out what exactly this payment that just hit my bank account, what it is. Note, even in the traditional bank world, like there are still a lot of times that this happened to Bitwave once. We got a $36,000 check that did we ever figure out who it was from? Like it was like literally, because if you don't put a memo field in, if they don't have a clean name, like if the name is like, John Doe XYZ Inc., you have no idea where this is coming from. So even in the traditional world, this is an issue. And this isn't a new issue. For a very long time, businesses that pay themselves or pay each other lots and lots of money have worked on different ways to create these remittance advice mechanisms between them. So that could be if you're Walmart and you have a supplier that you buy, a million things from. So you are doing 100 invoices a day. You're not doing those manually. You are doing that through an automated mechanism where you are basically shipping them an XML document, or you're shipping them. There's a whole bunch of there's like 20 different protocols for this stuff. And so you are shipping them something that's like, hey, I just sent you this transaction. Here's an XML document that describes the transaction that you can pull into your ERP. And it's actually going to close the loop between you sent us an invoice a month ago. We're sending you payment today, a month later. Here's a document that helps tie those two together. It tells you this is the invoice we're paying. This is the amount we're paying. This is like all the expectations that we have for terms and all that kind of stuff. So that's what we're here to talk about, which is that payments, I don't know, we gotta find a good term here. Like payments don't stop when you hit the send button. Like payments are an entire life cycle from before you click the send button to like after the other counterparty receives that money, and how you make it all work. So that's what this is. So on-chain payments, if what I just said, if we even in a traditional banking world ended up with a $30,000 check that we didn't know who it came from, imagine what the crypto world looks like, where you don't know, people randomly move their addresses around, because that's a best practice. Like for operational security practices, you should be randomly using different addresses. You should not only have one address for your business. So the address that the money is coming from is not necessarily clear. The address it's going to might not be clear. So you might have one single address that you use for your entire company. You might have one address you use for for each vendor, or you might have one address you use for for each invoice. Those are all different options for how you can kind of organize your crypto payments. People do every single one of them, but like it requires an amount of intelligence from your operational finance team to know that. Like you have to have a finance team that is super good at crypto to know, oh, the best way to do this is that every invoice should have its own address associated with it. And the thing is that's easier said than done, because there's cost that goes into that. Because like every one of those addresses, you have to pre-fund that account potentially, or you have to do it with one of the newer protocols. That's the account abstraction stuff. So you don't have any of the structure. There's no memo field that you get to put on your invoices that you're paying through. Like that's not the way it works. There's been some protocols that have kind of proposed that piece, but it's missing there. You don't have any context. And then honestly, like you really have a very high, if you are Coinbase, if you are Walmart, Walmart's trying to get into stablecoins, there's a high regulatory burden to actually do this work. So you need to be able to prove to your auditors. So you're not just saying, hey, this payment was to me, I'm good, I'm just gonna accept this. You need to be able to prove to your auditors that payment was intended for you, and that you booked it in the right way, and that it didn't come from somewhere like from North Korea or something like that. So that's like why. So on-chain payments are amazing. It's the fastest thing in the world to do. But the problem is it is not great for what we think about all day, which is how do you do your accounting around digital assets. And so like why this matters now, I don't really need to tell you guys this because everyone here knows this, but like, we're moving up to $100 billion a month of like flow through on stable coins, which is incredible. So there's this explosion of stable coins. More and more people are getting paid. B2B payments are one of the absolute killer use cases. I was having a nice long conversation with Amaya, I think, who was the guy, the VC who spoke first this morning. Super interesting guy. And he loves stable coins for retail use cases. I hate stablecoins for retail use cases. I think credit cards are an amazing retail use case because everyone, like, you spend money, you buy groceries and you're going to Hawaii, like slowly, but you're going to Hawaii. And that's like American consumers are terrible. But that's how our minds work. But B2B payments are where this is at, because if you are someone like Google and you're moving $1 billion around a month, the float that you are giving away. So when you do an ACH, they pull the money out that same day and they deposit the money 2-3 days later. That's interest that if you're doing something at the $1 billion a month scale, that's tens of millions of dollars a year of interest that you're basically giving up to float. So there's actually real use cases for stable coins for B2B enterprises that want to be able to capture float, move it faster, or negotiate harder on terms. Like, a typical accounting use case would be you give someone net 30, which means that you have to pay me in 30 days. But the thing is that like the way that generally works in current financial systems is actually it's more like net 35. That like on day 30, I click the pay button, it gets pulled out of my account, someone holds it for 3 or 4 days, and then deposits into your account. That's a really typical flow. That flow is essentially friction that's in the system, even if you don't necessarily think too much about it. So that's what we're all kind of thinking about here. And so there's 2 different protocols that are out there right now for how to do remittance advice. There's like 20 protocols, but I'll talk about 2 that are kind of like big in the ecosystem. So ISO 222 is a general protocol for doing. It's a XML-based protocol for doing remittance advice. So it means when I send you a payment, there's this XML file I can send along with it that essentially it describes the shape of the payment and allows me to import that into my ERP and basically pick up that transaction data. So this is it's super interesting. It's not well designed for the on-chain world, which is to say it doesn't really have free-form transaction IDs. So the transaction IDs you might have in there are not necessarily great for the for what we think of as like transaction hashes, where you can have super long hashes and weird shaped hashes and all that kind of stuff. The remittance files themselves are huge. Like if you ever worked with XML, it's this like monster format that it explodes in size. And so you could never take an XML document and put it on chain. I mean, you could, but you'd be paying like $100 to do it. And so it's like and then the other side is there's no actual, and this part is crazy because I saw a stat once that said that the average SMB, which would be a company under 5,000 people, loses something around $250,000 a year to bad invoices. So have you guys heard about this? There was that guy who would just randomly send Microsoft and Google invoices, and they would just pay them. Like this was like the guy made, I think he ended up going to jail, but he made like $10 million over the course of like 6 years, where he would just send him an invoice for like 20K, and then they would just send it back. And like honestly, part of the issue there is that there's actual in a lot of these invoices, these like interchange formats, there's no security built into it. They don't have signatures. They don't, like all the stuff you'd expect from like a modern day protocol. They didn't have any of that stuff built into it. And so this is all the issues with ISO, the 222. The other protocol that was recently announced was Circle announced this thing called Recibo, which is essentially, it's a smart contract that's tuned to ERC20s, where basically you can approve this smart contract for your ERC20 flows, and then you can attach a small amount of kind of like encrypted metadata along with it. So it just puts encrypted metadata on your on any sort of arbitrary ERC20. It has a bunch of different issues but the biggest one is that it's not a protocol. Like it is a smart contract interaction that allows you to put encrypted data in kind of like attached to an ERC20 transaction, but it really doesn't actually tell you how to interpret that data, where the invoice is, like all the different stuff you actually need to turn that into something you would use on the other side. So the problem with that is that it's not great for cross-company stuff. So as I'm going to be talking about this today, one of our goals at Bitwave is as we were working on this really exciting idea of remittance advice on chain, one of the things we want to do is like there are lots of people doing payments on chain today. Like Bitwave is one of them. There's folks like SAP recently got into the game. So we wanted to build something that a protocol that was basically out there that would allow a Bitwave payment to get ingested by the SAP Digital Currency Hub, and all that to kind of work seamlessly together. And so the Recibo doesn't do that. It's a mechanism for allowing you to encrypt some data on chain, but not to actually do this like interchange between the two different guys there. So we spent all this time, and what this ends up happening is it takes a long time to reconcile this data. There's a bunch of different issues that happen on the other side of this, but like one of the big ones is that if you are in the unenviable task of doing on-chain receivables, like you have a wallet that has 100 payments into it. Let's say your business is $500 a month. So you have 100 $500 a month payments, and you got to figure out how to apply those. And you got to figure out who's paid you and who hasn't paid you. Like that is a non-trivial problem. Like we all sort of forget about it, but like this is like the nuts and bolts of what it actually takes to do the hard work in the world here. Like how this is like how underappreciated your accountant is at your business, I think is a good way to also put this. It also means that you are losing all the context that comes along with it. You are potentially missing people that are not paying you, or you are misapplying these applications, all that kind of stuff. And more of the thing, it just means the people that are doing crypto accounting have to be so specially trained. Like this has been continued to be an issue around crypto accounting, is like it's so complicated. You can't just have anyone do it. Like you have to have people that are really specially trained on this. So, okay, so we've been working on this. It's baked into our protocol now, and then just today we are actually open sourcing this for anyone to get at. So it's called Strip. which is the Secure Remittance Information Protocol. The original name was the Cross-Chain Remittance Application Protocol, but the crap wasn't a great acronym, so we had to rethink it. But we got a better one today. And the idea is that it's built to be both for on-chain, cross-chain, and off-chain remittance. It is a encrypted byte string protocol that basically is a way that anyone can build to it. It gives you a bunch of different ways to basically. So the goal here will continue to be that like we as Bitwave can send a payment to someone that uses SAP, and SAP can automatically pick it up and apply it. So that's what we're going to be talking about here. So there's 3 core principles that we picked up as part of the application here. So first is the way that the Circle Recibo worked is it was focused on smart contract interactions and was very tightly coupled to ERC20. It was very tightly coupled to EVM chains. We had this idea that basically we work with Stellar, we work with Ripple, we work with all the EVM chains and base chains and Bitcoin, all these different things. Whatever it is we're going to build, we have to build it in such a way that it allows you to work cross-chain. So the way you actually do that is you do this based off of log messages and byte and like opcodes, as opposed to just doing this based off of like one really strict ERC20 extension format. So we did that first, where it's events and log centric. So if you see this on Ripple, they have an event model. Ethereum obviously has the log messages that get built, all that kind of stuff. It's designed for very, very wide interoperability. So the way we've designed this protocol, and I'll get into it a little bit more, is that you can use it to transmit an ISO 222 document. It obviously doesn't get embedded in that because that'll never work on chain. It's too big. So you can use it for ISO 222, but you can also use it for smaller embeddable on message, like on chain payloads. So this is a really cool part of it, is you can either use it for on-chain payloads, or you can point to an off-chain payload in a secure way that you can actually then have validation around, stuff like that. And it's designed to be very discoverable. So like if you can give your public key you can give your public key to an auditor, and they can find all of the payments that have been made to you as a company just by looking at the blockchain. And that's actually really important. Like the ability to independently produce a data set is something that auditors find very important. So like one of the issues, if anyone here is working with Lightning at all, one of the big issues that comes up with Lightning is that in order for an auditor to know all my transactions, I basically go to my node, I do a pull of all the invoices, and I hand that set of invoices to the auditor. The problem is auditors can't use that. Like auditors literally can't use a set of data that I pull independently and hand to you, as they can use it for informational, but they can't use it as their audit, like the audit level stuff. They need to do an additional level for that. So being able to actually look at these messages on chain, to give them a public key, and then they can go and find all these transactions on chain is super, super, super valuable. And this is why I just keep getting back to over and over again. Like Bitwave needs to be able to send a transaction on any of these blockchains that a completely separate ERP system, whatever it is, out there finds, pulls up, and actually automates into it. Okay, so I'm going to spend just a couple of minutes. I won't go too much into this. I don't know how who's a programmer in the audience? Are there programmers in the audience? All right, good. All right, nice. 3. All right, guys. So when I say things like magic byte, you guys have to like go and explain it to everybody else. But that's fine. We'll do that afterwards. It's all good. So this is how we're kind of handling this. We designed out a byte format, which is very easy to embed, and relatively, it's a little bit verbose in certain situations, and we're kind of playing around with ways to shorten it. But we are optimizing for security and discoverability over shortness, which are those are the 2 ways you're going to kind of do this. So basically what happens is you get a log message. There's a data component of that log message that has this stuff embedded in it. You can just take that, you can take it and you sort of parse it apart by these rules. So we start with a magic prefix. That's going to be SRIP, is basically going to be the magic prefix we're going to start with. There's a encrypted payload. So the way we did this is you either have a full payload, which is and I'll kind of show this, but you can either take the entire message that has like the invoice ID and the person you're trying to pay, and you can basically build that, compress it, and put it right in the message on chain. So in that case, there's no need to go off chain for any information. You can have the entire invoice remittance advice entirely on chain there. We use a hash key so that you basically, however you encrypt the payload, we hash the key for that, and we salt it and hash it, so that anyone going through can very, very quickly find the messages that are relevant to them. So when there are billions of log messages that go over this stuff, you can basically use this very, very quick model to take the salt, take the key, hash it, and compare it to this key identifier. And that allows any auditor to basically go through an infinite set of these log messages and pick up what they need to. And then the coolest part about this is we also then include an HMAC, which allows you to add security to a document you might be referring to. So if you transmit a document over the top, so if you take like an ISO 222 XML document, you put it on your server, what you can embed in the log message is actually a hash of that, so that there's now security and confidentiality built into it. So now I have this we've basically built an on-chain mechanism for doing security around ISO 222 that had never been there before, that actually has like high validity and stuff like that. So here's what the format looks like. I won't spend a ton of time on it. Basically, we'll have this available for folks to kind of look at and play around with if they want to later. Here's what an embedded format might look like, where you basically have a tag that we are using. We kind of just we have, as part of the protocol, we define like one really simple embedded payload, which uses basically a protobuf like message itself with a really simple tag in front of it. So like a hex version of I, and then the protobuf message. So that way, anyone that sees, you see a flag that basically says, you see a flag that tells you that it's an embedded payload, and then you see the embedded payload itself. If you see an I there, then you know that it's a protobuf message like that you can just pick up and use. That then gives you the invoice ID that you as your organization could use. That's usually how you do remittances, is that like, I am paying this $100 to pay invoice 1234. So this lets you kind of do it there. And there's some additional optional fields there if you need it. And then this is what an actual transmit would look like if you're sending over a URI. So you basically take your URI. This is the document that gets saved up on your server. It all gets embedded, and then you take an HMAC of you take a hash of the actual document embedded on the message. So now that when I go to get that document, when my system sees this come up and I know it's to me because my hash key matches, I can now go. I grab that document and I check that the HMAC you gave me is what's actually what I'm actually pulling. So you have now added a layer of security, on here for this piece of it. For developers want to do it, there's a developer guide online. It's on our GitHub. Basically, what you're going to do is there's a log message. There's a formalized log message name on Ethereum, Ripple, all the different EVM chains. You pull that up. You parse the version prefix. You run through the verification of the hash key, and then you use your shared key or your public-private key to actually decrypt it, and then validate any docs you need to on that side. So it's super easy to do, and we'd love folks to start working on it. And this is the kind of thing that, like Borderless, you guys could build. You guys could build this into your payment product, into your creating the actual invoices. You could build this when you get them to actually like denormalize this and put it into a place that you could have available in your API, all that kind of stuff. And this is kind of what we're looking for here. Is we'd love anyone to check it out and like make comments on it. So it's Bitwave Corp/srip on GitHub. So please check it out. Please feel free to file issues, or if you have any thoughts on it or anything like that. We'd love to get some more embedded standards going. So we created one very simple embedded standard that was really like an invoice ID, which wasn't meant to be the end of the world, but it's a cool idea. So if you have other ideas for how to do embedding standards, like, basically, if you want to have loan repayments or intercompany transfers or interbank transfers, there's all these different models that people do that we can start to like format really simple embedded formats for on this side. We launched a implementation on Ripple, Stellar, and EVM chains, but that leaves a lot to be desired. There's a lot of guys out there like Bitcoin chain, Bitcoin obviously, and all the UTXO chains, which need to have a slight modification of the protocol to really work with it. But then obviously all the other like Cardano and all these other guys that are out there that we just haven't had time to build up yet. We'd love to see other cross-chain implementations. And then, really where we are today is that this is in an alpha phase. So we'd love to get feedback on the protocol, and as we build it out and move towards like a 1.0 version of it and all that kind of stuff. So that's it. That's what we've been working on. And if whoever has the best questions, we got some T-shirts. You have to ask questions, demanding questions, and then you can get a T-shirt, or you can just not ask questions. I'll just give you a T-shirt also. So awesome. Thanks so much, everybody.
How many T-shirts do you have?
We have like 3 T-shirts. We have 3 T-shirts. Any questions? Anything anyone wants to know? Or even we can talk about payments in general, or like the accounting around payments is also a fun commentary here. Yeah. So institutions, it's all about the instant settlement, intraday settlement of the stable coins. Like that's the number one thing that all these guys care about, is that like everything's fun and games, but at the end of the day, like most of the institutions are still doing settlement at end of day. And so like if you're doing repo, the minimum repo time you can do is I can borrow paper money overnight. And that's in fact, like I was talking earlier about like float, like the way that float works is they're taking that money and they're putting it into the intraday markets. And so they basically, however many nights you can keep the market, however many nights you can hold on to someone's float. So I send out $1 million, the bank's going to hold that for 3 days and then to give it to the person I'm sending it to. Those 3 days, that money goes into repo markets and overnight paper markets, where basically because they do inter-day settlement, where it's like settlement only happens at the end of the day, you basically are in the situation where you can't really move that fast and you have to hold it one day. With stable coins, you now can get in a situation where you can really do, like a bank can borrow $1 billion for 5 minutes. And it's funny because this is like, I love this idea because crypto, one of the things we did really well was flash loans. Like flash loans, there's not that many things that were like unique to crypto. Like AMMs, the protocol was unique, but the concept wasn't like of a trading thing like that. There's all these things that like that. Like flash loans were kind of unique to crypto. This idea of like in one single block, borrowing $1 billion, doing something with it, and then paying it back is super unique. It's super unique to crypto. And so in fact, like that's one of the things that's getting the institution super excited about stable coins is that suddenly you're opening those kinds of things up for them to do. Because what trader at Goldman wouldn't love to create some absolutely insane, asinine 42-leg trade that happens instantaneously off of a flash loan where they borrow $1 billion from, you know, Warren Buffett or whatever. So I think like that's one of the things, like the instant movement of stable coins is one of the things that we are seeing people get so incredibly excited about in the institutional space. And that's absolutely bringing a lot of folks into this stuff. That man gets a T-shirt if he wants it. Yeah.
So if you can take are you a software development company developing protocol, or are you also in the payment execution and management business?
It's all good. Bitwave, we do digital asset back office software. So we essentially make a suite of tools for accounting, tax, and then now payments. So we don't, Borderless would be, you know, we partner with Borderless where they do the orchestration one layer beneath us. We do the step above that, which is pulling together the invoice that, like, you know, you receive the invoice, you need to get it formalized, get into a system. People need to approve it. You need to often integrate with NetSuite. You need to gather your vendor information. So gather the address, gather all that kind of stuff. We do all the application level stuff for the orchestration, orchestration piece. And then also accounting and tax if you're touching that kind of stuff. That man gets a T-shirt because he let me pitch the company more. I mean, that's what else could you ask for? Any other questions? Anyone else want to just rap about any of this kind of payment stuff? We got. Oh.
Yeah.
But the question is like how much training actually the company needs to use stablecoins, to use crypto. I mean,
you know, yeah, such a good question. So the way that I tend to think about this is I do tend to think that most people are going to start using crypto in high volume without realizing they're using crypto. So I think that goes to institutions where they're going to start, like, what's going to happen is their trading terminal is going to start having a mechanism to borrow $1 billion. It's going to have a borrow $1 billion button if they need an instant billion. And for them, they will have no idea that it's backed by Canton or USDC under the hood. They won't care about that. They'll click that button. They'll suddenly have that trading power. They'll settle it within like half an hour, and then they'll move on to that. I think that most of these guys are going to abstract it away. A lot of the folks are building big development groups. So like a lot of like the Fidelities of the world, they have, I think, it was EY or JP Morgan has 300 developers working on crypto stuff. So I think you need to start building up the developer expertise because that's completely different. And I don't think that if you've been doing like financial development for the last like 50 years, I don't know what the hell you think about crypto. I think that it's like very uncomfortable and stuff like that. So I think that it's like getting new blood and like really like figuring out the new protocols and stuff. But I don't think it changes the trader's day at all. Like if it's done correctly, it won't change their lives at all. Awesome. Well, thanks so much, everybody. Really appreciate your time. Oh. Oh my God.